But here, this example is interesting because this is the patient intake example from Pipecat Flows. And you can see that there are 8 steps that the bot needs to complete. And ideally, well, really, it's mandatory that the bot completes all of them. So this is an intake call for it to be a viable product. It needs to extract all of this information. Ideally, it would do every single step once. It would do it in an order that makes sense. Like you wouldn't want to start with allergy information and then the reason for visit and then ask the birthday and all sorts of things. So you'd want it to run through in a very like structured way. So there are risks with this.
Good morning, good afternoon, good evening, depending on where you are in the world. Nice to see all of you today. Today, we welcome back Mark to talk about instruction following, scripting, creating reliable workflows, whole bundle of stuff that you hit as soon as you get past your demo stage with your most voice AI applications. Even as the models have evolved over the last 2 years, this problem has not become any less pressing. Getting the LLM to balance the amazing freeform conversational abilities that provide so much value and are like a brand new thing in the world of computing with actually doing things reliably that you wanted to do, especially as your use cases get more and more complex, is a challenge. There's a bunch of different ways to approach this. We've tried a bunch of different experiments in the Pipecat world. Mark is the motive force behind a state machine library called Pipecat Flows. That's one way to solve for these challenges. So as usual, we'll give some Pipecat Flows examples, but this is a very general thing we all face. And please feel free to talk in the Discord channel about all the tools that you think are useful in this regard. As usual, please mostly talk in the Discord channel. We can keep the threads and the conversation going after this session if we do it mostly in Discord rather than in the Zoom chat. I will throw it over to Mark.
Thanks, Quinn. All right, how's it going, everyone? Sorry if there is a little background sound. We'll see how good Zoom's noise cancellation is. There are chainsaws down the street cutting all the trees down, which is sad. Scripting or workflows or state machines, there's a ton of ways to refer to this. We're going to get into this today. So I was reflecting on the talk and or the topic and was thinking about my own journey, and I think this may resonate with others, just so what it feels like, what kind of the path is, and it's interesting. So I was thinking about you have this initial beginner. I think everyone starts somewhere. We run a quick start. You might have some ideas. You get overconfident. You think, I'm going to be a billionaire. This is going to be easy. Just that initial burst. And a lot of the tools, of course, like getting started is really easy with many. But you quickly, I'd say over the course of days or weeks, you get into this like crazy phase where you might be stuck in like prompt engineering hell. And you had this simple thing that worked really well on a quick start, and then all of a sudden your prompt is 5,000 tokens long, and you're wondering what the hell is going on. This tool worked so well, but maybe I'm losing it. What's the deal with LLMs? These things suck. At least I went through that. We built a product called Ambient Scribe, which created doctor's notes for folks. And anything in the prompting world or getting an LLM to do something complex is actually a pretty difficult task. Eventually, though, you emerge on the other end and you have that confidence. You're this grizzled old veteran. You've spent many late nights and worked your way through. Maybe realizing that LLMs are computers after all, and if you use some specific tactics or structured approach, you can actually get to something that works. And we all want to be like Robert Redford, so maybe we can aspire that with our developer skills. All right, on to the serious stuff. So I think a lot of people will know what's happening in kind of the basic slide, but I think it helps to start from the very basics, like how what an LLM does and how that is cast into a real-time context. So first, you have an LLM. It is performing a chat completion, even in the context of real-time AI, which is just an instantaneous like snapshot. You provide it discrete piece of information, so some context or a series of messages that we'll just refer to as shorthand as context. The LLM will run a completion of that. In the voice AI context, you have the user and bot taking turns. LLMs are very much like turn-based when you start to work with them in this manner. So if you speak to it, it's going to speak back, which will then have the user speak, and then the bot will speak back. So they become like, whether it's intentional or not, very much churn-based. You can see this from the early applications like ChatGPT and all the way through to real time. But each time you go through this conversation, you're actually growing the context. So the user speaks, we're aggregating messages into the context. The bot speaks, we're aggregating those messages into the context. And this could be tools, tool calls, responses, etc. You may be injecting messages into the context, but at every turn, the context window, which is finite, you're growing and reaching that in a full kind of limit or capacity that it has. And with each turn, things are getting more and more complex. And oftentimes, LLMs are extremely verbose unless you really try to tamp down their behavior. So this, within, say, like a 5-minute conversation, you could very easily get to, maybe in some cases, if you have a really large initial prompt, towards the end of a context window, depending on the model that you're working with. So as this grows over time, you start to hit a lot of complexity. I don't have an actual, this is just like hand wavy of how things might actually look. I don't actually know what maybe someone out there has studied this, but over time, like as your context window grows and or rather as the context size grows, for a while, for a decent amount of time, and this is in the context of real time for voice, over the first few minutes of a conversation, task following is going to be pretty reliable. But without fail, and you can hit this fairly quickly. It could be 7 or 8 turns into a conversation, depending on the model that you're working with, but the ability for the LLM to provide the desirable output. We talked yesterday about evals. You might think of or have a model of what success is getting through an entire prompt, or what you've set out for the LLM to do with the prompt. But without fail, as that context window grows, LLMs will start to either forget things or be recall less reliably things from earlier in the conversation, or altogether just stop doing the things you want it to do. I did see just this morning someone who's I can't recall the name, but in the Discord community made a post about how LLMs are getting so good. And maybe this person is actually in this session, I don't know. But that in fact, you don't need something like script following or things along these lines. I work with this stuff every day, and I can say with certainty that that is not true. So I think this still represents the state of the world as of all the current state-of-the-art models. You may trade off, for example, I think Anthropic might be the best in terms of its task following over large contexts, but it's slow. So there's always trade-offs. Obviously, cost grows extensively as well. So I would say no matter what, that you're going to see some tail off. You're going to get less optimized results the further things go. Now, maybe it still achieves the result, great, but I do think at some point you're going to see reliability fall off. And the biggest factors there are going to be largely, I think your prompt really matters. So how specific the prompt is, your initial prompt length, and also just the context length absolutely compound and make things difficult. Tied back to your prompt specificity will be your tools. So how easy it is for an LLM to determine what tool to call based on how specific your prompt is. Also, how many tools you have allocated to the LLM. If it has 10 tools to be used over a 15-part conversation, it's going to be pretty difficult for it to actually do the right thing at the right time. So this is something that you could very easily test out by just having a mega prompt or like some monolithic single prompt and try to have something go from an LLM go from A to Z. There's other considerations, of course. You are limited. So even if LLMs were perfect, they have finite context windows. So you can't just run a conversation forever. We have customers, or I guess developers in the community, in the Pipecat community, that have calls that are 15, 20, 30, some that are over an hour long. SuperDial is building on us, and they do insurance negotiation around healthcare, and their calls last upwards of 90 minutes. So you need strategies just simply to ensure that your conversation can continue, because if you run out of the context window size, your conversation is over unless you take action. And of course, cost. These things have to be viable. There are economics that back all of this. So if you're not being token efficient in what you do, you're going to have a hard time running a business. The services altogether are, I would say, still as real time and voice AI are still very much on the cutting edge. The cost is certainly, it is not, or it makes use cases not all a fit for all products in the world at this moment. At some point, I do think it will get there. But one aspect of it would be the LLM. The LLM is not the most expensive either. But if you're using a state-of-the-art model, you can certainly find ways to cost optimize through more efficient prompting and use of the context. So there's a lot of things to consider. You might be thinking like, well, what the hell am I supposed to do? What are my options here? Let's look at a few of them, and then we'll actually take this into a path that is an application. This will terminate in talking about Pipecat flows. So this is my personal experience. I'd be very interested to hear from folks in the community what you've learned or in the audience have learned. First off, managing the context length. There are ways to go about handling this. The default for essentially every voice AI application would be just appending. So back in your user to bot ping-ponging, every time one speaks to the other, you just append. So every time the context is growing, and it grows to over the course of the entire conversation. This is the simplest approach, and it's part of every strategy to some extent. If you're running calls that are, say, like on the order of 1 to 2 minutes, that's amazing. You probably only ever need to append and don't need any complexity. Your prompts are also maybe sufficiently simple that a lot of this doesn't apply. So appending is the first start. Things are working great. Keep it simple. The next thing, actually bumped into this in working with Gemini Live. They implemented this recently where with speech-to-speech models and their audio context, which can grow like to be extremely large very fast, they've implemented a sliding window, which I think is a pretty interesting strategy. The way that for Gemini Live that they speak about it is provide like a token count. So you may say the last 4,000 tokens, let's maintain a sliding window where it just moves along and has memory for just a portion. I'm not sure if they're doing anything under the covers of like a sliding window and summary. The risk of just a simple sliding window, though, is that there's forgetting. Anything at the initial onset of the conversation might be lost if it's not mentioned or reiterated later in the context. So that certainly can be a risk factor. I would imagine maybe there's a fifth strategy of as you slide, maybe you continually do some type of summary and inject like kind of some basis of important information in that window. But this can certainly help. It would also you would have a very solid understanding of your cost as well, since this is capping the tokens as the conversation progresses. Another one, this is really handy. We've used this in some of the examples, even on conversations that are as short as even like 10 turns to summarize and reset. So the idea here being that you would use some out of band, so outside of the conversation flow, LLM calls. So you may do a direct just post to run an inference on the summary of the conversation. And it can be as simple as saying, here is the conversation thus far, and it would be the entire context with a prompt to give it a little bit of instruction about what you're interested specifically in extracting from that conversation. And that's going to be very much application or use case specific. But the idea would be that you would create a summary, and then in the subsequent turn for the next completion, your only message in the context, it may be a new system message, or I guess really depends on what LLM you're using. Let's say for OpenAI, it might be a new system message. You're going to overwrite the entire context where you have maybe one message that just says, the user and agent are having a conversation. Here is the summary of that conversation. And then every subsequent message can be appended to that. And you can run that strategy over and over again. You have certainly some amount of loss, like lose fidelity of the conversation, and it's only as good as your summary prompt. But it is a way to fight against the context growing to be too large and having forgetting problem from the sliding window, and it can be fairly token efficient when you think about cost. So the last strategy is like very specific and would only probably apply in a handful of cases, but just simply resetting. There are cases where it makes sense to just simply restart a conversation. There's an example later that I'll talk about briefly, but the context is a patient intake conversation where we have an example where the very first thing the agent does, it asks for verification of the date of birth. So the user would verify. Once that step's complete, that information is no longer relevant. You can simply reset, throw away that part of the conversation, and then reload with whatever the next subsequent task is for the prompt, either your monolithic single prompt or some type of chunked set of prompts. But this is an interesting way to ensure that anything that might be distracting can be removed when it's just simply not required. Again, very like specific or targeted, so you'd have to know what you'd want to do with it, but it is certainly an effective way. Simply resetting could be taking the existing context, having some type of parsing, your application logic may parse and then just replace a smaller version of the same context. So there are certainly a bunch of ways you can think about handling this, but this is likely a strategy for everyone at some point is thinking about how, at least acknowledging what your strategy is with regards to the context growth. So next would be just simply prompt chunking. So this would be starting to move in the direction of scripting, where this is an example from one of our Pipecat Flows examples where I had an LLM take my chunked prompt and just fold it back into a single prompt. I've seen, and this is like an eye chart, so don't worry about what it says. It's just like, this is a long prompt. This isn't like really anything compared to some prompts I see because some will be on the order of 5 to 7,000 tokens and just putting your best into that initial prompt and writing it to with the utmost specificity. And that's great. That is definitely a good starting point. And like I said out of the gate, if that works, that's fantastic and can keep things simple. But here, this example is interesting because this is the patient intake example from Pipecat Flows. And you can see that there are 8 steps that the bot needs to complete. And ideally, well, really, it's mandatory that the bot completes all of them. So this is an intake call for it to be a viable product. It needs to extract all of this information. Ideally, it would do every single step once. It would do it in an order that makes sense. Like you wouldn't want to start with allergy information and then the reason for visit and then ask the birthday and all sorts of things. So you'd want it to run through in a very like structured way. So there are risks with this. I think the biggest thing that I would say is probably the biggest thing at risk would be not completing all the tasks. It's difficult because just the way that LLMs are getting better and better all the time, but I think it's certainly what I've seen is skipping over, or I'd say the other biggest risk factor would be non-compliance with using or calling tools. Each one of these might be a database call with a specific piece of information. So you will write different function calls for each one of these. They may use different information to go and log the information. So it could be hard for the LLM to figure out which one of these to actually use. And maybe you roll it up into a single, call this endpoint, or function call. It's like your call endpoint function, which may simply work, but would certainly be use cases where you're going to have multiple tools that look and smell and taste like the same. So this would be an area where I've personally seen in doing development, even with chunking the prompts, where LLMs will fail to complete the task. Repeating is also, I think, probably the other risk is going back, like some type of repetition in the conversation that's not desired. A strategy for this would simply be to chunk. Chad on the daily team was the first one I saw do this, I don't know, probably almost a year ago at this point in time, where he took the append strategy. It was a really great approach, novel approach to this, and it worked really well, where the LLM was fed just the very first part. So from this long prompt, this introduction and date of birth verification, the LLM context would be set only with that message. So its only job at that point in time was to do that. Once that was completed, there would be you'd use the append strategy and push a new context or a set of messages to the context about collecting medication, and then allergies and on and on. Looks like I have medication twice in here, or medical conditions. The idea being, though, that for an LLM, they have this very discrete, like task-oriented approach to things. Now, they aren't meant to, every time the conversation happens, go back to that initial system prompt and or try to understand from the conversation that's happened what to do next. Instead, you can feed them with the most relevant information as the last thing in the context, which they will pay attention to more readily, and then complete that task. Each time it may be a function call to go and log information, like in the previous step. But the nice thing here is you're very likely to get a much greater compliance. So back in this slide, your reliability may taper off if you're using the append method, but it might taper just slightly. You're less likely to see the non-compliance with tool calling, and you're much more likely to see things happen in the order that's laid out. It's not foolproof, but it certainly is something that is going to increase the odds of getting through or the likelihood of getting through the conversation and for the agent to do the thing that it's meant to do. And if that's the whole point of it is to complete the task, collect the information in this context, and be hired to do the job. So let's look at taking some of these ideas and boiling down. The last thing is technically just a state machine, very simple. But these flows look like a lot of like call trees that we may have seen like days of yore, but they're effectively just state machines. Not everything is going to run from A to Z. In fact, many use cases I work with developers on don't look like that. You're going to see something, this is just an arbitrary flow, but you can imagine you go from one node to the next, you have a split decision. You may have nodes that loop back based on certain criteria. Maybe the user asked to, hey, I didn't actually want that. Let's go back to the decision point and on. So it's to have a single prompt execute a state machine like this is going to be very difficult. The actual state machine that it executes is probably going to look different, and you're going to have less control over the outcomes. So this is back to chunking and applying kind of more of that transitional logic of what to do after something completes. Let's move next into an application of this. Pipecat Flows is an application of this exact thing. Pipecat Flows is a framework or library built on top of Pipecat. So in the Pipecat context, the core Pipecat is your pipeline. It has all the services. It's for maybe simple terms, it's like the talking machine. It's the thing that knows how to do the job of talking to the human and running completions and outputting audio. So it's like the mechanical part of that flow. Its job is to do the talking. Pipecat Flows is a layer on top. It's really an abstraction on top of Pipecat that uses all of its frames to basically for the sole purpose of running a structured conversation. It is effectively a context management library. I get a lot of questions about, there is confusion, I think, and what does Pipecat do? What does Flows do? You can think of Flows as just simply how do I manage and run an effective conversation? How do I make my conversation execute like this? The way that it works, and this is just our own construct, this is just one example. You could build this in any way you want. You could write your own version of Flows, in fact, or your own library to do a similar thing. What we dreamt up with Flows was that every individual node in the conversation is, and borrowing from like a graph structure, every node contains a certain number of things. It has the ability to define the role. So for this specific node in the state machine, who am I? What am I supposed to do? Oftentimes that's defined at initialization and doesn't change, but sometimes it does depending on what the use case may be. The task messages are the task to complete for any given node. What is the job? So back to the patient intake, the task message would become collect medication or collect allergy information or collect medical conditions. Function calls are a special thing in flows, which we'll talk a little bit about, but these would be tools to execute that correspond to the task message. Actions that occur either before or after your LLM interaction. And actually, it's something we're working on improving today. And then context strategies. This is something we added a few months ago after hitting a wall and building out, or working with customers and building out, or developers and building out use cases, realizing that we couldn't just simply append, that we needed to have integrated strategies. So we have baked into flows the append, which is the default mechanism, and then the ability to, on either a global or per node basis, reset and summarize. So back to function calls. So function calls can take two forms. One, within a given node, you can just run a function call to perform a task. Function calls also can correlate very directly and strongly with the task. So if the task is collect the patient's date of birth, collect and verify the patient's date of birth, when that function call, which might be verify date of birth, is called and you get a result back, at that point in time, you have the ability to assess, but was the task complete? So we refer to these in the Pipecat Flows terminology as edge functions. So the edge being the transition point from one node to the next. So when a function is called, it is the trigger mechanism to transfer between nodes. So this whole kind of concept is just this like more object-oriented structure for a node. So every node looks and has the same structure, but can be then defined programmatically of how when a node executes, it has inherent to it the task it will complete, and where it can move within the graph. So applying this is a really basic, we have a demo for this, for taking a reservation at a restaurant. Out of the gate, you might define the first node as being the role of, your reservation assistant, greet the user, and then there's a tool assigned, which is collect party size. So when the conversation initiates, either if it's a phone call, the user might say hello, then the bot would respond, or if it's like depending on the application, maybe the bot starts speaking first. After this task completes, so the bot might say, hey, what's your party size? The user would respond, party for two. At that point, it would run a function which would execute, let's say, collect that information stored in state. And once that completes, move on to the next task, which would be time. So let's collect the time, and on and on. We don't have to walk through this, but it's interesting because, again, back to just even for a very simple use case where you want to collect the size of a party, the time someone wants to join, and then gracefully say goodbye and leave the call. The state machine is simple, but it's something that it might be hard. It would be interesting actually to see what an LLM would do just with kind of a bare prompt. How well could it navigate the situation? Because there are cases where, say, like availability isn't, you may have conflicts with times. So in a real world situation, maybe it's reaching out to like OpenTable to get reservation availability times and log that, but you may have to loop back and ask again, prompt for time again. Actually, I think this no availability is supposed to go back to time selection. So you'd have kind of this potential like cycling through and need to be able to move from state to state progressively. Whereas if, let's say you hit that dead end and there was no availability, it may be hard to get the LM to go back and reuse a tool because it may have already said, hey, I used this tool. Why would I need to do it again? Let's just progress the conversation on. So it certainly becomes helpful. Also from a code perspective, I highly recommend there are these dynamic flows, which let you define each node as a function. So you can have this like very compartmentalized logic for each little code snippet becomes just a simple function that you can call, or a handler that's a simple handler. We also have, you can define it as static JSON. That's another way to use flows, but it's something that gives you a lot of flexibility to handle moving through your state machine. So transitioning a little bit, this is not the only way to do things. You can also approach solving complicated problems in a different way. Quinn has talked about this as workflows. If you've read the Voice AI guide or book, workflows are something that are generally like orchestration tools, and this is actually Pipecat to the core. This is exactly what it does. And this may be extend beyond a single agent system into multi-agent coordination. So this could again be at maybe a higher level. We haven't thought what flows looks like or state machines look like on top of a multi-agent system, but I guarantee at some point in 2025 that will come up. But we've started to dip our toe into the world of multi-agent systems and multi-agent coordination. And one really unique thing I think that may be truly unique to Pipecat is its ability to run parallel pipelines. With a given pipeline, you can actually run multiple LLMs and have multiple audio outputs from the same individual bot process. So the way that these parallel pipelines work are that they receive all of the same frames in the same way, but they can run their own logic separately. So you may have conditional logic like filters or gates that have each agent experience the conversation in a different way. So this is a little bit of an abstract way to look at it, but just to introduce the concept at a basic level, I recently built a demo built on Gemini Live that does this exact thing. And it's very much like workflow oriented or in a way its own kind of state machine. But it's a pretty interesting flow. I'll walk through slowly on this because it is detailed, but it's an interesting take. This is a word game. If you've ever played the game Catchphrase, we named it something else. It's called Word Wrangler. But basically, you have the user offering clues and agents guessing. So in this case, you actually have a host that tells the user the word, because the idea here is this is the context is a phone call. So you have a host LLM that speaks to the user and tells them the words to describe. You have a player that's also an AI assistant or bot that its sole job is to listen to the user and guess, to make guesses. The interesting part here is you need to use a lot of these like more complex mechanisms to isolate who can hear what. So in the case of the host needs to be able to hear the user to some extent. They need to be able to hear, actually, they need to hear the user, because the user can skip or ask for a new word. They need to hear the player, because the player is the one guessing. The user, of course, hears everyone, but the player itself only hears the human user. So in this, the user would speak, and their audio goes through both legs of the pipeline. On the host side, let's forget about this consumer processor at the time. Host is going to hear what the user says, and because it's Gemini Live, it's going to be an audio in pipeline. But we need to do some parsing. So the speech-to-speech model doesn't work for us. So we actually change the modality to be text out. So on the output, we've instructed the LLM to respond in a certain way. So when it hears descriptions from the user, it's just to respond, ignore, just ignore. And we're actually filtering that out so it never makes it into being verbalized by or turned into audio by the TTS. So that flows through this leg. So that's the user input on this side. You have the user input on the right leg, which is just simply going to the player. And there's some work we do around a kind of gating and making sure the timing is right. This is very much in the workflow case. You can check out the code if you want, but the idea here is that the player is always going to hear the user. And the player's audio needs to both be outputted and routed back to the host. So Alesh, who's on the daily team, he does a lot of work in Pipecat. I'm sure you've talked to him if you've done any Pipecat development. Added these new processors where you can produce and send frames. Think of it as like a portal or something from one place to another. This can be either legs of a parallel pipeline or maybe even across potentially or theoretically different pipelines. But as the player audio is outputted as raw audio, we then transform it into raw input audio and send it into the host. And all of that is just this machine that runs continually. So very much different than the state machine, very much workflow oriented, but something that helps to you think about if you can really think about and break down your workflow. You can even take a very complicated situation where you have multiple agents in the same process run. This is the type of thinking, and it does take some understanding of how specifically whatever framework you're using, in this case is Pipecat, can work. But the idea being that there is like a lot of flexibility to be, or agents can be very versatile, and the tooling in particular in Pipecat can afford some of these really interesting use cases where you can have multiple agents communicate in the same context. I would recommend checking that one out. I think with that, I may be at the end. So some examples to try. So from Pipecat Flow, some of my favorites. We talked about the restaurant reservation. Really simple, but from a learning standpoint, it's fantastic. On the right is the patient intake example. It is a static flow, but it's one that takes, it's the first aha moment for me when Chad built it, that it takes a fairly straightforward process and just chunks it into very discrete steps, which I think is just a great way to solve the problem. And then the last is a warm transfer. I presented last week on telephony. As a reminder, a warm transfer is when a user would call and speak to an agent. At some point, that reaches a point where the agent needs to transfer the human user to another human user. Instead of just handing them off and forwarding the call, the agent can put the user on hold and the agent can brief the human and before connecting them. But this is a really interesting task that would love to see just a single LLM prompt accomplish this. It is something that is a fairly complex thing, and these function calls also need to be like very tightly orchestrated where they're putting the user on hold or swapping out their tracks and playing hold music for them. It's all done in the context of a single daily call. In this case, it's a single WebRTC call, but it heavily leverages like the state machine aspects that Flows offers. So it's more than just prompting. It offers like some insight into how to control the actual kind of mechanics and audio flow in a call. So that's definitely one. It is, I would say, the most advanced by far, but if you're interested in this type of thing, it's something that it certainly can teach you a thing or two. So with that, I think that is all I had in store for today.
Thank you so much, Mark. Really fantastic discussion in the Discord, too. I'll try to hoist some things out of the Discord as usual and talk about them. I think the overall question here is often how close are we today to being able to just use prompts and naive, simple concatenation of the multi-turn context, and not need any scaffolding? I think it opinions vary widely depending on what you're doing. If you're doing something that's really narrative, you can just use the LLMs today. They're great. Like they're really good. at keeping the thread of a conversation going in an open-ended freeform way. They're even good at needle in a haystack stuff. So if the use case you're pushing on the edge of is at some point previously in the conversation we talked about some specific thing, the LLM needs to not forget that. The needle in a haystack abilities of today's SOTA LLMs are great. And they're great because the lab's trained for that. That is a metric you can define, and then in your post-training process, you can hill climb on that metric, which I think brings up a really important point. We work closely enough with many of the folks training these SOTA LLMs that we know for a fact multi-turn stuff is very new in their prioritization, in their data set creation, in their metrics internally that they can hill climb on. Even non-audio multi-turn was not a big focus until really recently. It is a big focus now. So I think we will see a lot of progress from the SOTA LLMs that make a lot of use cases not need any scaffolding at all. But I still think we're an LLM release or two away from getting there. It's not just about context length, it's also about what the LLMs are trained, what the transformers emphasize and damp in any given construction of context. So I do think it's important to think about two things. One is function calling, instruction following really decrease as context lengths get much longer. That's something you can quantify. What's much harder to quantify is, does the LLM do what you want it to do as the multi-turn conversation builds up? And that's not only about length. It's also about just the structure of the data you're feeding the LLM and what data the LLM saw when it was being trained. I had a really fun conversation at LlamaCon about this with Zach, founder of Ultravox. Zach's perspective is you should never need any scaffolding. You should always be able to prompt the LLM to do these complicated things. The LLMs are great. And I think that's an awesome perspective. And I think Zach is amazing at using his models and the Llama family of models in ways that I'm not as good at. So I found that to be a really valuable perspective. He was basically like, you just need to treat Llama as something that is incredibly literal. So you prompt it differently from how you prompt 4.0 or Gemini Flash, but if you prompt it correctly, it will do instruction following. The other leverage Zach has, of course, is that he does post training on these LLMs, so he can add data, and they build APIs and they can build scaffolding internally inside their API boundaries. So just pointing out, there's lots of different points of leverage to solve this problem. But a bunch of people ask what context length size rule of thumb there is. What's too big? And I don't think that's really the right question for most of the complicated workflows we're talking about. I really think it's less, is there specifically too big a context size? And more, what do you want the LLM to do in this particular moment in the conversation? And in your evals, does it do it? So we're back to the session yesterday about how important evals are. If you don't have evals, you don't really have any way of knowing what percentage of the time the LLM doesn't do the thing you want it to do for that kind of moment or that structure of the context. I think the date of birth example in the medical patient intake workflow is a really good one. What I've seen is that if you leave the date of birth exchange in the conversation, most of the time that doesn't matter. But if you run a bunch of conversations, you will see the LLM bring back up the date of birth later in the conversation when a human wouldn't have done that and when it's not that relevant because LLMs are trying to be super friendly. And like you told the LLM, all the SOTA LLMs now are trained to be very human pleasing. You told the LLM at some point your date of birth. It thinks you think that's important. It is not unlikely to bring that up later because it thinks you think that's important. I'm like totally anthropomorphizing, but I think the anthropomorphizing here is like useful because we're training these things to be anthropomorphized. So if you take the date of birth out, you remove that failure mode or that non-optimal mode from the conversation flow. The other thing about context length, of course, is cost and latency. I'm really curious whether anybody here has good benchmarks on time to first token as context length grows for the LLMs we all use, because I don't think we do at daily, although we should actually look at all our metrics with that in mind. This is a really good reminder. It's been on my personal list for a long time to add the context length tracking to metrics so we can figure that out. It's really hard to benchmark for that, partly because for all the TTFT benchmarks, you have to run them a lot over a long period of time and average out the results you get, and partly because the labs are doing things like adding implicit caching, which is awesome, but also like you don't even know what you're necessarily benchmarking. So we see wider variations in things like TTFT for traditional like multi-turn conversation use cases. Does anybody have great like latency versus context size numbers?
Quinn, I will repeat something I said in the Discord, which is that it has gotten a lot better over the past couple of years, I would say. Like when I first started building like patient intake and stuff like that, it was noticeable how like this is probably like GPT 3.5 and GPT like early versions of GPT 4 days, and that itself has gotten so much better that one, I think if you're using the right model, you're already well within what is acceptable human latency. And also, for other reasons, it can be advantageous to have more of the previous conversation in the context window. And this feels to me like one of those things where are there optimizations to be made here? Sure. But also, if models are going to keep getting better and better about still being performant with even very large context windows, are we doing premature optimization by trying to pull previous conversation out of the context in a way that we might not realize could be useful for later parts of the conversation?
All our friends who work at the big labs are like, just build as if the models are perfect and there's zero latency. And I'm always like, yeah, okay, okay, great. But what do I do today? Because they're not
Well,
wrong,
and
right? The models are getting better, shockingly fast, but it's hard.
the infuriating answer for all these questions in a session like this is that you won't know the answer for your use case until you go do a bunch of evals and find out exactly how long you can talk to your particular bot until it starts going off the rails and all that kind of stuff.
This is also a case where I'm always impressed by the ability of the people at the big labs to manage their supercomputers. Training the models is magic, but in some ways, as an infrastructure person, I'm like day in and day out more blown away by just the managing the supercomputer aspect of it. Because I think Chad's right. The latencies correlated with prompt length, context size have gotten much less variable. You can feed much longer prompts and get good TTFTs. That is definitely not true when I run Llama 4 on VLLM or whatever, like even with KV caching, it's not the same thing. So there's magic in the infrastructure layer too. A few questions about in the state machine approach. So the kind of standard way of thinking about Pipecat Flows world. How does going back to a previous part of the conversation work?
I'm assuming the question is like the mechanical part of that.
I think maybe it's just worth both stepping back and thinking and talking about what the goals are and what maybe some different goals are in different kinds of conversations, and then like mechanically how do you actually implement it. So if the user's, oh, actually my I forgot an allergy medication, let me
Right,
tell you
right.
about this other medication.
Yeah, this definitely is a case where, for example, like the reservation one is a good example where you can actually bake that into the state machine where if the time isn't available, you have to go back to the time collection node or state. So it means really looping back to re-execute a task that had been previously completed, like on just a plain like English standpoint. What it means then from like a technical standpoint would be reloading the task specifically into the context. So it'd be putting it as the most recent message so that the LLM knows that this is the thing that is relevant to do right now. And you can either append or you could use some strategy where you go and either augment or reset the context. For most simple things, you can really just go back and have it reiterate. But Quinn said these are really in the people pleasing or progressing the conversation type mode. So they're going to speak back to the most recent thing that they heard. So this is where you get the power of just appending the most recent part of the conversation or most recent task. If you're looping back and the LLM outputs something like, sorry, that time isn't available, you append a task that says your job is to determine a time that is suitable for a reservation. That is added to the context, and then the user says something like, hey, how about 5 o'clock? And it's going to say, run a function call to see is that time available, come back and say either yes or no again. So from a pure mechanical standpoint, it's very much about just putting that task right at the as the head of the queue so that the LLM can execute that, knowing that's like the job to do at this point in time. I don't know if that answers the question, but and Quinn, maybe you have a different take or can expand on it, but effectively, like that's what's happening to when you think about going back in a conversation.
Alesh asked a version of it. A bunch of people ask a version of it. Maybe Alesh wants to say what he was asking.
Sorry, I couldn't unmute. Hey, everyone. Yeah, I was asking like in Pipecat Flows. I think I know the answer, but I'm going to ask it just for everyone to know. In Pipecat Flows, in the restaurant example, let's say, or if you're ordering a pizza, it doesn't matter. You say the party size is two, and then you keep going with questions. But then at the end, you say, you know what? We were four instead of two. So how does Pipecat? I know that if you prompt the LLM, it just without Pipecat Flows, it will know that you have updated the party size and it will continue there. But what happens in Pipecat Flows? Will it go back to the node with the party size and then the pre and post actions will be executed again, or what? How is that handled?
So you have to be explicit. So this is like maybe the one thing to consider if you're going into manual mode, you're truly going into manual mode. So in addition, like each node has tasks to complete, but it also has available tools. So if you want to instrument your flow such that the user can at any point in time go back to in the restaurant reservations case, if they can at any point in time ask, hey, actually I want to change my time. You need an exit criteria from that node that knows to go back to that state. It doesn't just happen magically because the whole point would be for it to detect, for the LLM to detect that the user wants to offer a new time, and it needs to know there has to be some mechanism to detect and then go back and reload the task. So if at the like the confirmation step, where right now I think in the example it's very simple. It's yes or no, and then it goes on to end. But if you wanted to support the user saying, oh geez, hold on, actually I had my schedule wrong. How about 6 o'clock? You would just have to have a criteria that says reschedule, and it would loop you back to that initial pick a time node. The nice thing about it is conversationally, it can be very natural. Nice. Yes, indeed. That is exactly the job for the LLM.
I have some
Easy to
things to
do.
say about this in a second, but I'll let you
Yeah.
finish.
But the nice thing about it from a conversational standpoint, it isn't like the LLM's brain was wiped. It knows you had this conversation already about the reservation. So it's able to like very naturally in the conversation say the next thing. Oh, it's okay. Let's actually go back and find a time that works, rather than it just be like purely like a machine. Just speak and ask just a very concise, direct question. So that is one of the benefits of having just this append strategy and keeping some buffer in the context that you're going to get a more natural response.
I've been looking for a way to shoehorn my explanation of how all this stuff works into this conversation. And Quinn, if you'll allow me, I will opine for just a minute. Fundamental to all of this, and this is how I've been thinking about this now, and Mark and I have been working on this for a long time. Like fundamentally, you have to remember that the LLM at any given moment, an LLM does not actually really have a memory. All it really has is what you tell it. And at every step in the process, whether you're using prompt chunking or just one big prompt, or you are using Pipecat flows or whatever, you're always talking like every time you prompt the LLM, that is a completely new totally from scratch conversation with the LLM. And that conversation has two things in it. One, it has a history of everything that you have gone, if you prompt it with it, it has the history of everything that you've gone back and forth with that LLM in the messages array. And it has a tools array. And this is why I was sharing this image because at any given moment, the only thing that the LLM is trying to decide is, okay, my tools are all of these buttons right in front of me. I'm either going to respond with some text back for the human or I'm going to push one of these buttons, right? And I think that this, like, what do I do about changing my party size last minute question comes back to this idea, which is fundamentally, whether you're using Pipecat flows or prompt chunking or whatever, all that the LLM is trying to decide is whether to respond with words based on what the user said or whether it wants to push one of these buttons. And so implicit in that is that you have to define the buttons that the LLM can push, and you have to define if and how and when it chooses to push those buttons. And so for something like, so when I built like the patient intake example forever ago, I had explicit function calls in there where basically when the user would list their allergies, if you look at the actual like prompts in there, it asks the prompt tells the LLM to essentially, when it thinks it has the complete list of things that this person is allergic to, whether that, and however it makes that determination is up to the LLM, but when it thinks it has the full list, call this function. And that function is like save allergies, whatever. And if you look at the actual like function callback, I'm literally making a like fake REST API call to something to save this list of allergies. Now, there's another way I could have structured this, and I could have said, you know what? And actually, somebody brought this up in the Discord in the context of doing like a tech support, like troubleshooting call. Instead, like when you're asking the person what model computer you have, what OS are you using, what's your browser version? Like instead of literally making REST API calls to save all that stuff, your function call could be adding that stuff into some sort of like specific, like state object in the LLM's memory. So like in the Pipecat context, it could literally just be like a Python dictionary where you're saving all this stuff. And at any time, you could essentially be giving the LLM a list of functions it could call to update any of that stuff. And also have a function that only chooses to save that to a database at the end of the call when the LLM is confident it has all of the information that it needs. And so a lot of times I answer all these questions very pedantically, which is to say the LLM is only going to do what you tell it it can do. And so if you are, for example, locking in the size of your of the party for whom you are making a reservation earlier in the call with an API call, then you need to make a function call earlier on to do that. And then you, in your Pipecat flow or whatever, it's going to be up to you to tell the LLM what to do if the person goes, oh crap, 4 people instead of two. Whereas if you're implicitly collecting all this stuff and then making one big API request at the end, the way that you structure the tools that are available to the LLM is going to look a little bit different. And it's going to give the LLM essentially more buttons that it can choose to push at any given time. So I can talk more in detail about how that works. And I guess the last thing I'll say is that fundamentally under the hood, what Pipecat Flows is doing is just managing this, is just managing the context that is being presented to the LLM for each completion, and also what tools are available to the LLM. And so in the case of Pipecat Flows, it is generating tools that allow that essentially allow the LLM to tell Pipecat Flows to move to a different node in the state machine. But under the hood, it's just this all the way down. It's just context management and function calls is all that it is.
Yeah, the state machine approach is still prompt engineering. That's probably a good way to think about it. It's prompt engineering with some extra structure to make to make dynamic prompt engineering easier. My mental model for it is you're really relying super heavily on function calling and function definitions because you're using the function definitions to give the LLM context about what states are available to it. And then you're also optionally, as Chad explained, doing a bunch of things that are specific to your use case about how you modify the system instruction in the context. But it's still prompt engineering. You should probably still think about it that way. There was a question about workflows where we call external agents using MCP or A2A protocol. I will drop Vanessa's MCP example into the Discord. There's a bunch of voice plus MCP experimentation going on. It's really fun. It feels a little bit early days for MCP, but there's so much excitement around it. I have not had a chance to play with A2A. Really interested to hear what people think of A2A. And if you have good Pipecat plus A2A examples, put them somewhere. I'll tweet about them. I'll try them out. And last question.
Gwen, can I
Pulled
jump
up.
in and say one more
Yeah,
thing
yeah.
about that real quick? Yeah, the other thing that I think is an interesting voice specific catch with all of that is and I apologize because I can't see who wrote the question at the moment, but it is almost certainly correct to think about the fact that's going to be slow. And I think that in a lot of like text back and forth use cases, MCP and things like that can feel a little bit slow, and that's okay because we're used to text chat being a little bit slow. But one of the things, and this even came up in one of the sessions yesterday, is the idea that if you either know in advance you're doing something slow or you put logic in your bot to detect when something slow is happening, it's helpful to use to use things like, and sorry again, this is Pipecat specific, but like Pipecat has the ability to just tell the bot to say some hard-coded text effectively. And so if you know something's going to take a few seconds or more, it can be useful to, when you're starting that, shove something down the pipeline to tell the bot to say, hang on a second, let me look that up. And oftentimes, even just a couple of seconds of speech is enough to buy you time to close that loop. But also, it avoids that awkward, just 2 or 3 seconds of total silence where now the user's wondering, is this bot broken or am I talking to a stupid AI? Even something as simple as just 1 second can be enough to like buy you time for that to complete.
I think that's probably a wrap today, unless we missed anything really big from the Discord. Lots and lots of stuff to talk about here. It'll be fun to keep the threads going. And show us what you're building. Show us your tips and tricks. There are some questions like, is there a good guide for differences in prompting different models? I actually haven't seen one. It's we all learn from each other in like little random threads. So if somebody wants to write that guide, I am sure people would find it very interesting. Although it's hard because you need good evals. So it's that circular logic where you don't really know until you have the evals. Always back to looking at your data, as Hamel said yesterday. Thank you, everybody. We will see you online.